Section: Introduction. In this section, we discuss the importance of information seeking and integration as a crucial cognitive process that precedes analysis and decision-making in various aspects of life. This process often requires significant time and effort. While search engines have transformed how we seek information, they still struggle to integrate web data based on complex human intentions. Recently, large language models, LLMs, have made impressive strides in reasoning and understanding language, but they still face challenges in providing accurate responses. We see a promising opportunity in combining the strengths of LLMs and search engines. The reasoning capabilities of LLMs can enhance the vast information available through search engines, potentially changing how we approach information seeking and integration. Previous approaches have treated this task as a simple retrieve-augmented generation process, which, while straightforward, often leads to subpar results due to a lack of depth in handling complex web information retrieval. We identify three main challenges. 1. Real-world problems often need detailed analysis and breakdown of questions before retrieving relevant information, which cannot be achieved by simply pulling web pages at once. 2. The sheer volume of web pages and the noise in information can hinder ILM's ability to integrate data effectively. 3. The rapid growth of web content can quickly exceed the context limits of LLMs, further impacting their performance. Inspired by how experts tackle real-world issues, we propose MindSearch, a straightforward yet effective multi-agent framework that includes a web planner and multiple web searchers. The web planner first breaks down a user query into smaller, manageable sub-questions that can be solved simultaneously and assigns them to the appropriate web searchers. To improve reasoning, the web planner models the problem-solving process as an iterative graph construction, allowing it to progressively decompose questions into subproblems through code generation. Meanwhile, each web searcher focuses on its assigned subproblem and uses a hierarchical retrieval process to gather useful information for the LLMs, enhancing the efficiency of information aggregation. By distributing the reasoning and retrieval tasks among specialized agents, MindSearch reduces the burden on individual agents, enabling better handling of lengthy contexts. This approach effectively connects the raw data retrieval capabilities of search engines with the contextual understanding of LLMs. To test the effectiveness of MindSearch, we conducted thorough evaluations on both closed-set and open-set question-answering tasks using advanced LLM models. The results showed a significant improvement in response quality, both in depth and breadth. Additionally, our comparative analysis indicated that human evaluators preferred the responses generated by MindSearch over those from existing applications like ChatGPT Web and Perplexity Pro. These results suggest that MindSearch, utilizing open-source LLMs, can provide a highly competitive solution for AI-driven search engines. In summary, MindSearch combines the information retrieval strengths of search engines with the reasoning capabilities of LLMs through a structured framework involving a web planner and web searchers. The web planner organizes the search tasks based on user queries, while the web searchers perform hierarchical information retrieval to address sub-questions. We also address context management within this multi-agent design. Section Summary. In this section, we introduce MindSearch, a multi-agent framework that combines a web planner and multiple web searchers to enhance information seeking and integration by decomposing complex user queries into manageable sub-questions, thereby improving the efficiency and accuracy of responses. By modeling the problem-solving process as a directed acyclic graph and utilizing code generation for dynamic reasoning, MindSearch effectively bridges the capabilities of search engines and large language models, leading to superior performance in question-answering tasks. Section: Web Searcher. Web browsing with hierarchical retrieval. In this section, we describe Web Searcher, a sophisticated retrieve and generate agent that accesses the internet to summarize valuable responses based on search results. Given the vast amount of content online, it can be difficult for large language models, LLMs, to process all relevant pages within a limited context, such as 8,000 tokens. To tackle this, we use a simple course-to-find selection strategy. First, the LLM generates several similar queries based on the questions provided by the web planner, which helps broaden the search and improve the retrieval of relevant information. We then execute these queries through various search APIs like Google, Bing, and DuckDuckGo, which return key information such as web URLs, titles, and summaries. We automatically merge the search results by web URLs and prompt the LLM to choose the most valuable pages for detailed reading. The full content from these selected URLs is added to the LLM's input. After reviewing these results, the LLM generates a response to the original question based on the search findings. This hierarchical retrieval method significantly simplifies navigating large web pages and allows us to efficiently extract highly relevant information with detailed insights. Next, we discuss LLM context management in MindSearch, which offers a straightforward multi-agent solution for complex information seeking and integration with search engines. This approach naturally supports long context management among different agents, enhancing the overall efficiency of the framework, especially when the model needs to quickly read many web pages. The web planner assigns search tasks to separate agents and relies solely on the results from Web Searcher, allowing it to focus on breaking down and analyzing the user's question without being overwhelmed by lengthy search results. Each web searcher only needs to search for content related to its specific subquery, minimizing distractions. This clear role distribution significantly reduces context computation throughout the process, providing an efficient context management solution for long context tasks in LLMs. Additionally, this multi-agent framework creates a simple pipeline for constructing long context tasks for training individual LLMs. We find that MindSearch can gather and integrate information from over 300 pages in under 3 minutes, a task that would take human experts about 3 hours. However, we must carefully manage context throughout the workflow, as focusing solely on the decomposed query from the planner can lead to the loss of useful information during the collection phase. Effectively managing context between multiple agents is challenging, but we find that establishing topological relationships through directed graph edges helps us maintain context across agents. Specifically, we prefix the response from the parent and root nodes when executing each search agent, allowing each web searcher to concentrate on its subtask without losing relevant context or sight of the final goal. We evaluate MindSearch on 2 main types of question-answering tasks: closed-set QA and open-set QA, reflecting both subjective and objective assessments of MindSearch. For a fair comparison, all models access the Internet solely through the Bing Search API, without any additional reference sources. In the open-set QA implementation, we curate 100 real-world human queries and collect responses from MindSearch, Perplexity.ai, Pro version, and ChatGPT with a search plugin. We ask 5 human experts to select their preferred responses based on 3 criteria: depth, breadth, and factuality. Depth refers to how thorough and detailed an answer is. Breadth pertains to the range of topics covered, and factuality measures the accuracy and reliability of the information provided. The final results are determined by majority votes, and evaluators do not know which model produced which response to ensure fairness. The evaluation results show an absolute improvement in the depth and breadth of the model responses, confirming the effectiveness of our web planner. By integrating code into the directed acyclic graph construction phase, the LLM can break down complex problems into executable queries while balancing time efficiency and search space exploration. MindSearch also explores more specific search topics related to the question, resulting in more concise and detailed responses compared to other models. However, we do not see improved performance in terms of factuality, possibly because more detailed search results can distract the model from the initial problem, especially when the LLM has limited long context capabilities. A natural future direction for MindSearch is to address hallucination issues during web browsing. Alongside quantitative results, we provide a qualitative comparison of responses between Perplexity.ai, Pro, and MindSearch to illustrate their performance differences. We observe that MindSearch produces more concrete and detailed responses, which we attribute to better planned search paths compared to Perplexity.ai, highlighting the importance of effectively decomposing human intentions in solving problems. Section Summary. In this section, we describe Web Searcher, a RAG agent that enhances web browsing by employing a course-defined selection strategy to efficiently retrieve and summarize relevant information from search results. We also introduce MindSearch, a multi-agent framework that improves long context management and task efficiency by distributing search tasks among agents, ultimately allowing for quicker and more detailed information integration compared to human experts. Section: Implementation Details. In this section, we evaluate our method across various closed-set question-answering tasks, such as Bamboogle, Musique, and Hotpot QA. To test the generalizability of our approach, we use both a closed-source large language model, GPT-4o, and an open-source model, Intern LM2.5-7b Chat, as our backend. Since we operate in a zero-shot experimental setting, we employ a subjective evaluator, GPT-4o, to assess the accuracy of our results on Hotpot QA. In our results and analysis, we compare our method to two straightforward baselines, using a raw large language model without search engines and treating search engines as external tools in a React-style interaction. We find that our MindSearch approach significantly outperforms these basic methods, demonstrating its effectiveness. This advantage is even more pronounced when moving from closed-source to open-source models, showing that MindSearch effectively enhances weaker models with broader knowledge and reduces hallucination issues. Regarding tool utilization with large language models, our tool learning framework allows these models to integrate smoothly with various tools, such as search engines, databases, and APIs. This integration improves the interpretability and reliability of the models while also enhancing their robustness and adaptability across different tasks, including reducing hallucinations, generating code, and answering questions. Recent research has focused on improving how tools are integrated into tool learning systems, with some studies enhancing retrieval mechanisms to ensure models access the most relevant tools for specific tasks, while others refine the model's ability to utilize retrieved information effectively. In terms of retrieval augmented generation, RAG, we see significant benefits in tackling knowledge-intensive problems, especially in open-domain scenarios with search engine integration. RAG enables large language models to connect with retrievers, providing timely information and effective solutions. It is also applied in various tasks, such as reducing hallucinations, generating code, and answering questions. Recent work has aimed at enhancing the retrieval component of RAG systems and improving the language model's reading capabilities. As large language models advance, some researchers are re-optimizing frameworks and redesigning training methodologies. For instance, SAIL trains models to focus on credible search results, while Self-RAG allows models to independently fetch and enhance their text generation. RQ-RAG improves query formulation through an iterative learning process. Our work integrates web search capabilities into large language models, improving response quality by retrieving valuable information from the internet. Finally, web automation agents have progressed from simple question answering tools to complex systems capable of intricate web interactions. Early models like WebGPT and WebGLM focused on QA tasks, but recent developments have moved towards more dynamic operations. MindAct and WebAgent illustrate this evolution, with WebAgent excelling in web navigation despite size-related deployment challenges. AutoWebGLM offers a practical alternative with strong capabilities and a smaller model size. The use of reinforcement learning and behavior cloning techniques is paving the way for more autonomous and efficient web automation, leading to scalable and versatile solutions for real-world applications. Our paper primarily addresses web information seeking and integration tasks with search engines, tackling key challenges through a multi-agent framework.